When we start solving, I should say factor and solve quadratics. If I gave you something, we spend a long time doing things like this, and if I asked you to solve that for x, you could do that, right? What if I threw a square here? You could still do it. How would you do it? Plus 3. And then, oh, before you square, yep, divide by 2. So that's easy, right? Right. And we all agree that this is a quadratic, yes? Why is that a quadratic? It has that squared, that's right. It has that squared. What if my quadratic there, remember I told you can always SAD map your way out if you see x one time? What if, though, let me go back. Thank you. What if I had something like this?
Oh, I know what to do.
Why? First of all, why can't I SAD map that?
Because you just can't.
Two x's. Do you see the two x's? I can't SAD map that. Okay, that's the difference here. So the question is, how then can I solve it?
Don't you like?
I could use the quadratic formula.
Subtract that 15 over there first, though. You got to factor.
You got to factor. That's the key there. And here's why. Let me tell you why. It's something called the zero product property, where if you have two things that are multiplied together that give you 0, which is essentially what happens when I factor, right? When I factor, I end up with two things that are multiplied together, and this equals 0. Yes? What has to be true about one or both of those two things? If two things multiply to 0, then what do you know? What's the only way to get 0 when you multiply? One of them 0. A is 0 or B is 0, right? So in this case, this piece would be 0 or this piece would be 0. Remember we've been getting 2 answers? We'll still get 2 answers, okay? So the way we're going to solve these is we're going to make sure they equal 0 first. Then we're going to factor so that we get those two pieces multiplied together. And if I'm going too fast through this, tell me, because, again, this is Algebra 2 review. Yeah. Oh, you already factored it? 6 and 5? Okay. Hang on, let me finish putting this and then we'll factor it. And then finally, we're going to set each factor to 0, which means each parenthesis, and solve individually. So Jerome,
is this the one where you have to add the answer to the 0?
No, you don't have to do that.
I thought it was like something you do, like.
No, you might have to in the beginning. Well, we're going to factor it just like we've been doing. Okay. So the first question is, does this equal 0?
Yeah.
Yes, right? So what I want to do, and I'm going to go to, has everybody got that? I'm going to go to the next page here, 2:11:15. So my first check is, does it equal 0? Yes, okay? And so you might say, well, when would it not equal 0? It could be that they're on both sides and you have to subtract or add to get them all together on the same side. And we'll do a couple like that, make sure you understand. So the second step is factor. Jerome has already factored this for us. 30x squared that adds to 11x, and you said it was 5 and 6. So those are going to be my two middle terms. It doesn't matter which one goes where. And now slash it. What's the GCF of the first two? 2 what? Leaves me with, how about the second 2? Leaves you with Uh-huh. That's exactly right. Yep. I'm going to write it out real quick and then we'll set it, but you're right. That's exactly right. Because I have x plus 3 is one thing, times 2x plus 5 is another, and they both equal 0, which means one of them or both of them must be 0. Good job. So these are easy solves, 1 and 2 step equations. X equals -3. And x equals -5/2. So I still get the 2 answers just like I got before. Easy. One more like this, and then I'll show you about zeros. How about this one? What's the problem here? Remember, the only thing the directions are going to say is solve.
It's way more than 1x.
There's way more than 1x. I automatically know I cannot SAD map that problem, right? Okay? Well, if I do that, if I move the 5x squared, it's going to make the x squared negative. Remember, I don't ever want to factor with a negative first number. That's what I would do. I would move this one and this one. And I'm going to do them both at the same time. If you want to do them 2 separate times, that's fine. Okay? I agree. So on the right side, I know everything cancels. That's going to give me 0, which was the goal, right? I have to equal 0 before I can solve a quadratic. It's going to be in any way that you solve it other than SAD map, you're going to want it to equal 0. All right, so I got 8x squared minus, All right, so I've got a quadratic, more than 1x. I can't SAD map, so it equals 0. I know I can factor it. So what's my first step here in factoring? Take out a 2. Good job. I was wondering if y'all were going to remember to do that first.
I didn't care. See, I figured that out like the last 2 problems. Because I was like, it was the most problem rule I could factor.
So you say you did figure that out?
Yeah, after a while.
After a while. That's okay. At least you got it.
One of them numbers.
You talking about checking for that GCF?
Yeah. One of them.
But the thing is, now this method will work. You can still do it. But I bet you won't forget to check for GCF anymore. That you did it so many times without, and then you went, oh gosh, I need to do that. Now you'll remember. All right. A is 4, -4 is B, and -3 is C, so I get -12. What multiplies to -12 but adds to -4? Which one's negative? -6, +2. Remember, if you do your negative first, it's going to make your life easier when you factor, okay? So I have 2. 4x squared, this is going to break down into -6x and +2x, -3.
You see, like how you did the -6x and then +2x. What I was saying that other day, I'll be switching them.
That's fine, you can. The reason that I say this is easier, if you switched them and you had 2x minus 6x, whenever you go to slash, you'd have that minus in the middle, and you'd have to change the last sign. You know what I'm talking about? But that's fine, you can. It's definitely not wrong. All right, so let's finish the factor on it. 2x is the GCF of the first 2, that's correct, as soon as my computer quits thinking. 2x minus 3, that's correct. Remember, if you don't see anything that you can take out, you can always take out a 1. That always works. This 2, remember, is just going to keep coming down with the problem. Keep coming down with the problem. What? I got 2x minus 3. I got 2x plus 1. Everybody with me?
Yeah.
Okay. Are we going too slow? Am I reteaching you stuff that you remember how to do?
No.
Okay. Okay. I don't want you to be bored. I mean, if you remember this, then we'll move on. But if we need it, we'll... I just felt like we needed it. All right. Why am I not doing anything with that 2 in front? I took it out, but remember, the zero product property says 2 or more things multiply to 0. 1 or more has to be 0. Well, yes, this is multiplied, but is 2 ever going to be 0? No. So it can't be the 1 or more pieces that's going to be 0. So you can just ignore that when you're solving. All right, I hope you all solved that first one. What'd you get? 3/2 and -1/2. Say that again. It doesn't have any impact on the solution. All right. Let me show you this, and it's the last thing. We graphed quadratics in Algebra 2. Do you all remember that? What did they look like?
Was that the ones we had
Parabolas.
over 1? No, we had one we had to go over
I think
1.
that Miss Twitty teaches it that way. I don't teach it that way.
We got to go over 1.
Yeah.
They got up 2. We got over 2. Up 2.
All right, so they look like this.
Oh, yeah. That's what we have.
Okay. They could go up or they could go down, right? And let's say this is the axis, and let's say this is the axis. There are some important points on here. We're going to talk about these important points today. What were these called? Those are intercepts. What intercepts are they? X-intercepts. What was another word that we used? Start with Z. Zeros. I was going to say there's not many words that start with Z in that. Zeros, right? Those are the zeros of the function. Now I want you to think. When you find the x-intercept of a line, or anything for that matter, how do you do that algebraically? Like when you just have the equation. Without using your calculator. Do you agree that at the zeros, y is always 0? In other words, look at the points. This might be 1, 0. This might be 5, 0. This might be -3, 0. This might be 2, 0. But every place it crosses the x-axis, y equals 0, right? So algebraically, if we want to find the zeros, we let y equal 0 and solve. Does that make sense? Why? Because y equals 0. Every time y equals 0, it's crossing the x-axis. That's what it has to do, right? So what we're going to do is we're going to look at some equations of parabolas. Let's say, for instance, now if I say f of x, remember that's just function notation. It's the same thing as what? Y, right? Let's say I said f of x equals 5x squared minus 25x plus 30. And I told you to find the zeros. What could you do? What do you do? Is that my computer that keeps doing that? What's wrong with it? Oh. All right, what do you do? What's always true at zeros? We just said it. Y equals what?
0.
So if y always equals 0, why don't we let y equal 0 and solve for x? Mm-hmm. This is the same thing as y, so if that's the same thing as y, make it 0. And then you solve it. Well, how do you solve that? Factor it. Factor and solve. But Monday we're going to be graphing the quadratics, so I wanted you to really understand what it is that we're doing here. All right, so how do I factor that?
You gotta take 5 out.
What's left? What multiplies to 6 but adds to negative 5?
Well,
3 times 2. That's 3 plus.
Close. You got it backwards. Right? No. I think Hope had it, yeah. What'd you say? Yeah, what'd you say? Didn't you say negative 3 and negative 2? I know she said it right before you. But she just wasn't confident in what she said. Negative 3 and negative 2, I had to think about it a minute. If it's multiplying to a positive, but it's got to add to a negative, one's got to be positive, one's got to be negative. I mean, both have to be negative. I'm tripping over my words this morning.
Wait, why wouldn't negative 1 and
Negative 1 and 6. Because that multiplies to negative 6 and not positive 6. And it's got, you see what I'm saying? That doesn't multiply to negative. I mean to positive. Plus negative. All right, so I have x squared minus 3x minus 2x plus 6. I'm going to slash it. Always wants to split my screen when I go up. All right. What do I take out of the first two? X. What's left? How about the second one? You're right, though. I am taking negative 2 out. And because it's negative 2, that changes. That's exactly right. So it becomes x minus 3. What'd you do? Oh, that's fine. So x minus 3, x minus 2, and now everybody goes to 0. The 5 doesn't really count because 5's not going to equal 0. But x minus 3 could equal 0, and x minus 2 could equal 0. So it's 2 and 3. So understand what this is saying. This is saying that whatever else my parabola is doing, at 2 and at 3 there are x-intercepts. So I don't know what else, but at 2 and 3 it's crossing the x-axis, okay? Does that make sense to everybody? Does it make dollars? You get it? Does it make enough sense that it makes? Hardy, har, har.